Trig graphs, number one, we're going to work backwards, 101 over 99. So we're going to do the reciprocal, 99 over 101.
And then if we know SOHCAHTOA, some old horse caught another horse taking oats away.
So 99 is associated with the adjacent side, and 101 is associated with the hypotenuse. So the adjacent side is going to be down on the bottom here, adjacent to theta. Opposite theta is going to be over on this side, and the hypotenuse is the longest side. So we have the 99 on the adjacent side. That's going to be on the bottom of our triangle. And our hypotenuse is 101. That's going to be on our opposite side, or our longest side. Now to find out what the opposite side is, we have to do the hypotenuse squared minus the adjacent side squared. So our calculator key in would be the square root of 101 squared minus 99 squared. And that gives us a 20. So our opposite side is going to be 20. Now once we have that, we can do opposite over hypotenuse, 20 over 101. Tangent is opposite over adjacent, 20 over 99. And then the reciprocal identities, we just flip them, 101 over 20, 99 over 20. To find theta, this angle over here, we have to do shift sine, the arc sine of 20 over 101. So on our calculator, we're going to hit shift sine. Of 20 over 101. And it gives us an angle of 11.42. So we'll round that to just 11 degrees. 99 minus 11 to find out what omega is. So 99 minus 11. And that's 88. This one, we're given a coordinate, 5, negative 2. So there's two ways to do this. We can plot it. We can go right 1, 2, 3, 4, 5, down 2. Draw our vector. Make our triangle. Theta is always close to 0, 0. The x-axis is always our adjacent side. The vertical one is always our opposite side. And our hypotenuse we would have to find by using Pythagorean theorem. Now be careful. When we do the Pythagorean theorem, it's going to be the square root of 5 squared plus negative 2 squared. But you can just do this. Because negative 2 times negative 2 is the same as 2 times 2. Square root, 5 squared plus 2 squared. Root 29. So our hypotenuse will be root 29. Our opposite side would be negative 2. Our adjacent side would be 5. Another method of doing this is called the CS method. So if I put a C over the 5 and an S over the negative 2, notice the word sine begins with the letter S. So the negative 2 would go on the top. The word cosine begins with the letter C. So the 5 would go on top. Now we automatically have our tangent. Our tangent is going to be negative 2 over 5. And I'll make that S look like a 5. Then we'll flip it. So that would be 5 over negative 2. And we already found our hypotenuse to be root 29. That would go on the bottom. That would go on the bottom. And then we do our reciprocal identity. So root 29 over negative 2. Root 29 over 5. Special right triangles. If the hypotenuse is 10, the short leg is going to be half of it. That would be 5. And then the long leg would be 5 root 3. Whoops. Just 5 there. And the long leg is 5 root 3. This is a square, so these tick marks mean that all these sides are 7. And the diagonal would be 7 root 2. So C would be 7. D would be 7. E would be 7, and F would be 7 root 2. This is a high level one. It's supposed to be 15 over root 3, but the shortcut is divided by 3, so it would be 15 root 3 over 3. And 15 divided by 3 would give us 5 root 3. So if this side is 5 root 3, we double that. This side would be 10 root 3. So G is 5 root 3, and H is 10 root 3. Amplitude period, amplitude period. The amplitude is that number out front. The amplitude is that number out front. The amplitude is that number out front. The amplitude is never negative, but it's still that number out front. It'll be a 2. To find the period, we have to do 2 pi divided by that number. So if your arithmetic isn't good, let's use the calculator. So we're going to turn it on, and we're going to hit the fraction button. And on the top, we're going to put 2, and to find the pi, it's down here. You have to hit shift and the button way down here. And that'll give us 2 pi divided by 2. And that gives us just pi. So our period is pi. 2 pi divided by 2. Calculator key in. So I have 2 pi on top, and I'm going to back arrow into there and do pi divided by 2. So second pi divided by 2, just like that. That's how I want to type it in. 4. 2 pi divided by 3. When we type that one in, 2 pi divided by pi divided by 3. So all I have to do really is back arrow and delete that and change that to a 3. So 2 pi divided by 3 will give us 6. 2 pi divided by 4, we'll let the calculator simplify it. So I'm going to back arrow and delete the bottom. And we're going to put 2 pi divided by 4 in there. And that's going to give us pi over 2. So we're going to graph the function. The amplitude is 2, so here's what that means graphically. We go 2 up and put a dashed line. We go 2 down and we put a dashed line. Always go right 4. 1, 2, 3, 4. And we find the period, so 2 pi divided by 1 divided by 2. So 2 pi divided by 1/2. Again, we can just back arrow and change that to 1 divided by 2. And that's 4 pi. So this fourth spot here is 4 pi. We're going to take half of 4 pi and go halfway. Half of 4 pi is 2 pi. Half of 2 pi is pi. To find the third spot, we multiply the first spot by 3. So pi times 3 is 3 pi. The word that we're graphing is sine, and sine always starts at 0, 0. It's a positive in front, so we go arriba, al centro, abajo, al centro for our first cycle or period of that sine graph. And now we're going to pop all of our other dots. So upper bound, midline, lower bound, el centro, arriba, el centro, abajo, midline, upper bound, midline, lower bound. Lower bound, midline, upper bound. And that's going to give us a whole bunch of cycles, or a period repeated several times. So there's 2, there's 3, including that at least 4 periods. Next graph, y equals 3 cosine pi over 3. Our amplitude is 3, so graphically that means we go 3 up, upper boundary. We go 3 down, lower boundary. We're going to go right 1, 2, 3, 4. Everybody get on the dance floor. 2 pi divided by 3. So we're going to type that into the calculator. 2 pi divided by 3. So pi divided by 3. And when we hit enter, it kicks out 6. So our fourth spot, we put a 6 there. Always go out 4. Put a 6 there. Half of 6 is 3. Half of 3. So you can do this on the calculator. Just keep taking 1/2. So while that's still in my calculator, I'm going to hit divide by 2. And that would give me 3. While that's still in my calculator, I'm going to hit divide by 2. and that'll give me 3/2. To find the third spot, we take that 3/2, and while it's still in our calculator, we hit times 3. And that'll give us 9/2. The word cosine starts at either the upper boundary or the lower boundary. Because it's a positive 3 out front, it's going to start at the upper bound, and then it's going to oscillate. It's el centro, abajo, el centro, arriba. And that's one cycle, or one period of this cosine graph. Then we're going to keep popping our dots. Midline, lower bound, midline, upper bound, midline, abajo, el centro, arriba. And it's going to keep oscillating. And then we're going to draw our curve. Y equals -2 sine pi x. Our amplitude is going to be 2. So we're going to go 2 up and draw a dashed line. We're going to go 2 down, draw a dashed line. Go right 4. 1, 2, 3, 4. Everybody get on the dance floor. To find our period, we put 2 pi over pi. I don't need a calculator. That'll be 2 because the pi's will reduce out. Now, I go right 4 and I put that 2 there. Half of 2 is 1. Half of 1 is 1/2. Multiply 1/2 by 3, and that'll give me 3 over 2. The word sine starts at 0, 0. However, it's a negative out front. So instead of going arriba, it must go abajo, down. Lower bound, midpoint, midline, upper bound. Midline, lower bound. El centro, arriba, el centro, abajo, el centro, upper bound, midline, lower bound, midline, upper bound. Upper bound, midline, lower bound. So whenever you see 8 plus bi, you want to take your calculator and go into mode 2. You want to go into mode 2 of your calculator. So mode 2, and you'll see it's misspelled at the top, complex mode. So I have to label the complex point. Notice this is a real axis and an imaginary axis. So I go right 1, 2, 3. So that'd be 3. I go up 1, 2, 3, 4 plus 4i. Now it wants me to find the magnitude or the absolute value of z. So the magnitude or absolute value of that would be in mode 2, shift height, shift height. And notice it says absolute value there. Shift height will get you the absolute value bars. And then we just type in 3 plus 4 English. Because you have to be in imaginary mode or complex mode to do this. Hit equals, and your magnitude is 5. I go left 2, up 2, so it's going to be -2 plus 2i. The calculator can. We'd have shift height to get the absolute value bars, and then we type in -2 plus 2 English, 2i. The English button is the I button. Just hit equals, and 2√2 is our answer, our magnitude. Oh, don't forget, we have to draw the vector and put an arrow on it. We have to draw the vector and put an arrow on it. We have to draw the vector and put the arrow on it. This vector is left, 1, 2, 3, 4, 5. Up, 1, 2, 3, 4, 5. So -5 plus 5i. Shift height, -5 plus 5 English. 5√2 is our magnitude.